Research and Evidence-Based Medicine, EBM, for 7th semester medical students. What is evidence-based medicine, EBM? Evidence-based medicine, EBM, is a systematic approach to clinical decision-making that integrates the best available scientific evidence from research, the clinician's expertise, the preferences and values of the patient. EBM teaches medical students to critically evaluate medical literature and use that evidence to improve clinical practice. Objectives of the Research and EBM course. 1. Understanding the basics of medical research, learning research methodology, study design, and data analysis. 2. Developing skills in appraising evidence, critically analyzing scientific articles to determine their validity, relevance, and reliability. 3. Improving clinical decision-making skills, using the latest evidence to support diagnosis and therapy. 4. Promoting clinical research, preparing students to contribute to the advancement of medical science through research. Components of the Research and EBM course. 1. Fundamentals of research. Research methodology covers experimental, observational, qualitative, and quantitative approaches. Example: case control studies, cohort studies, and randomized controlled trials, RCTs. Data collection, sampling techniques, data validation, and tools for data collection. Medical statistics, descriptive and inferential data analysis. Example: using t-tests, chi-square tests, or regression analysis. 2. Principles of evidence-based medicine. Steps in EBM. Identifying clinical problems. Example: what is the best therapy for hypertension in diabetic patients? Finding evidence, using trusted sources like PubMed, Cochrane Library, or scientific journals. Appraising evidence, evaluating the strength and quality of research, internal and external validity. Applying evidence, translating research findings into patient care. Evaluating outcomes, reviewing the impact of EBM application on patient health. 3. Critical appraisal of scientific articles, reading scientific articles critically by addressing key questions. What is the purpose of the research? Is the research methodology valid? Are the results relevant to a specific patient population? 4. Research proposal and report writing. Students are typically required to draft a research proposal as part of their final block assignments. A proposal includes problem background, research objectives, study design, planned data analysis. 5. Applying research in clinical practice, using research findings in real clinical decision-making. Example: choosing appropriate antibiotics based on microbial sensitivity test results. Evaluation in the Research and EBM course. Academic assignments, Critical appraisal creation. Critiquing a scientific article, often from the latest journal related to specific clinical cases. Group discussions, discussing EBM applications for given cases. B. Research practice. Research design, defining research problems and study designs. Data collection and analysis. Students analyze data using statistical software, SPSS, R, or others. C. Final exam. Usually a written exam to assess understanding of EBM and research methods. Example questions. What are the advantages and disadvantages of randomized controlled trials, RCTs? How would you evaluate the validity of a case control study's results? Case studies in EBM. A case study 1. Therapy selection in diabetes. Problem. Is metformin more effective than sulfonylureas for obese diabetic patients? EBM steps. Searching for recent studies on diabetes therapy. Comparing evidence from various clinical trials. Applying the evidence to the patient while considering their specific condition. B. Case Study 2, Antibiotics in Pneumonia. Problem. Are broad-spectrum antibiotics more effective than narrow-spectrum antibiotics for community-acquired pneumonia? Solution. Reviewing meta-analyses comparing both antibiotic types. Selecting therapy based on microbial sensitivity results and patient conditions. Challenges in research in EBM. 1. Limited understanding of statistics. Many students struggle with complex data analysis. Solution. Intensive statistical training. 2. Irrelevant literature. Not all research is applicable to the local patient population. Solution. Reviewing contextually relevant research. 3. Dependence on information sources. Students may lack easy access to paid journals. Solution. Using open access resources such as PubMed Central. Expected competencies. 1. Ability to design research. Students can plan and conduct simple research. 2. Skills in critical appraisal. Students can evaluate the validity and relevance of scientific evidence. 3. Use of EBM in clinical practice. Students can make clinical decisions based on the best available evidence. 4. Collaboration in research. Working effectively in teams to produce quality research.